Good morning, sir.
Yeah, good morning. Am I audible clearly? Am I audible clearly?
Yes, sir. Yes, sir. Yes, sir.
Okay.
Yes, sir.
Okay. So today we will see the all the formulas related to noise, so that we can solve any numerical asked from this topic with the formula for the noise figure and the noise temperature. So the questions which are asked in your university exam may be related with these things. Also, there will be numericals related to this topic in the computing exams also. So let me share the whiteboard. So क्या आप सभी लोग चैट बॉक्स में अटेंडेंस दे रहे हो डेली बेसिस में?
Yes, sir.
ओके, बीच में फिर से एक बार मैं अटेंडेंस शेयर करूंगा आप लोगों के साथ, लेकिन अगर अगर चैट बॉक्स में आपका अटेंडेंस नहीं है, इन दैट केस अटेंडेंस आपका वेरीफाइबल नहीं होगा। स्क्रीनशॉट में तो रहता है अटेंडेंस, बट ऐसा होता है बहुत बार कि स्क्रीनशॉट में नहीं आ पाता है ड्यू टू वेरिएशन इन द पोजीशंस। सो आप लोग रेगुलरली चैट बॉक्स में अटेंडेंस दिया करो। अभी जैसे मैं यहाँ पर देख रहा हूँ 24 पार्टिसिपेंट्स हैं, बट चैट बॉक्स में अभी तक सिर्फ 16 अटेंडेंस आया है। Okay, I am sharing the whiteboard. Whiteboard देख पा रहे हो?
Yes, sir.
Okay. Okay. So जो हमने अभी तक देखा है नॉइज में, बेसिक जो डेफिनेशंस के साथ जो फॉर्मूला हमने देखा है, तो बेसिकली नॉइज रेजिस्टेंस के लिए हमने फॉर्मूला देखा, उसके पहले नॉइज पावर के लिए। सो लेट मी स्टार्ट विथ नॉइज पावर सेल्फ। सो related with noise. Okay. फर्स्ट हमने जो देखा है नॉइज पावर. ओके, सो नॉइज पावर जिसे हमने पीएन से डिनोट किया था. सो दिस नॉइज पावर वाज गिवन बाय KTB, where K is the Boltzmann constant, T is the absolute temperature, and B was the bandwidth over which the noise is calculated. Okay, the second one is the noise resistance. So noise resistance जो हमने calculate किया था for multi-stage amplifier, वो क्या था? R equivalent is equal to R1 plus R2 by A1 square plus R3 by A1 square, A2 square plus R4 by A1 square, A2 square, A3 square plus dot dot dot. Okay, so when there is a multi-stage amplifier, so for that case, we have got this thing. Okay, the third one. So the noise figure. So noise figure can be calculated with the noise factor, and the noise factor. So noise figure के पहले noise factor देखते हैं. Noise factor. So noise factor is given by. So this is nothing but the. So noise figure is nothing but the ratio. So what is that ratio? Can anybody tell me what the noise figure is? Noise figure is a ratio. So what type of ratio is this? Nobody. Noise factor is what? This noise factor. So noise factor is the is related with the input and output. So input and output कहने का क्या मतलब है? So input and output मतलब SNR, sorry, SNR input to the SNR output. Okay, so this is the noise factor, and when this noise factor is expressed in decibel, then it is known as noise figure. So in quote, we can say that noise figure is equal to 10 log base 10 F. So F here is what? F is the noise factor. So when the noise factor is expressed in terms of decibel, so the unit here is dB. Okay, then it is said to be as noise figure. Okay, so next is fifth one. Noise figure can be given in one more term as F is equal to, so it can be given in terms of the equivalent resistance. So 1 plus R equivalent by RA, where RA is what? RA is the antenna resistance. Okay. And R equivalent, if you know that R equivalent is the equivalent noise resistance. This is equivalent noise resistance. Okay. Sixth one. नॉइज रेजिस्टेंस हम नॉइज फिगर हमने देख लिया. नॉइज फिगर को हम इस तरीके से दिखा सकते हैं. अभी नॉइज फिगर फॉर cascaded amplifier. So noise figure for cascaded amplifier. So this formula is somewhat related or looks same as the equivalent resistance as F1 plus F2 minus 1 by A1 plus F3 minus 1 by A1 A2 plus F3 minus 1 by A1 A2 A3 plus like this. So yes, next is, so this is the equivalent noise figure for the cascaded amplifier for the case of cascaded amplifier. Okay, next seventh one is the, so noise figure for the cascaded amplifier is that the multi-stage. So you can say it as cascaded amplifier or multi-stage amplifier. Okay, next is the noise temperature. So firstly, what this noise temperature is, what we have seen earlier, that the noise power is given as KTB. So here T is what? T is the absolute temperature. So हम क्या जानते हैं कि जब भी noise होगा, so that noise will be due to the temperature raised in the circuit. So this temperature can be termed as the noise temperature. So when it is termed as noise temperature, then it can be written as Tn is equal to Pn by K times B, where B is the bandwidth, Pn is the noise power, and K is the Boltzmann constant. Okay, so this noise temperature can be represented in terms of noise figure as Tn is equal to T0 F minus 1, where this F is the noise figure, and T0 is the room temperature, T naught. So room temperature T naught can be taken as, in most of the cases, you will see this as 17 degrees Celsius. Okay, so that 17 degrees Celsius can be converted into what in terms of Kelvin. Okay, so you have to be in mind that noise temperature is nothing but the temperature due to which there is noise power within the whole circuit. So this is represented in terms of noise figure in this way. Next is the eighth number. So we have seen this, the noise temperature, and this noise temperature. So if we find out the equivalent noise temperature, so equivalent noise temperature will be for the multi-stage amplifier or the cascaded amplifier. So equivalent noise temperature. So what this equivalent noise temperature is, it is written or given by the formula as we have found out the expression for noise figure also. So it is written by T equivalent 1 plus T equivalent 2 by A1 plus T equivalent 3 by A1, A2 plus T equivalent 4 by A1, A2, A3, like that. Okay. So where A1, A2, A3 are the gains for the particular stage. So A1 is the gain for stage 1, A2 is the gain of stage 2 amplifier. So this is the equivalent noise temperature produced due to multi-stage amplifier or the cascaded amplifier. Next, the ninth one. So इसके अलावा क्या छूट रहा है? Let me see once. Yes, we have calculated the noise voltage also. We have calculated the noise voltage previously. So noise voltage Vn is equal to root under 4 RKTB, where these R may be in series or parallel based on the configuration. Okay, so this is the noise voltage. So these are the formulas related with this chapter, and these are very much important from the point of view of your university exam as well as the competitive exams also. So I am आगे बढ़ने से पहले एक चीज यहाँ पर थोड़ा सा क्लियर कर देना चाहता हूँ that ये जो नॉइज फिगर हमने यहाँ पर देखा है, नॉइज फिगर फॉर कैस्केडेड एम्पलीफायर हमने ये जो देखा है, तो while doing calculations हमें एक चीज यहाँ पर ध्यान क्या रखना है, for the case of this noise figure, that ये सारे क्या होना चाहिए, F1, F2, F3, A1, A2, A3, all these F1, F2, F3 and gains A1, A2, A3, अगर ये dB में दिया है, अगर क्वेश्चन में ये सारे dB में दिए हों, तो आपको ये ध्यान में रखना है कि these F1, F2, F3 and A1, A2, A3 should be in fraction form. ओके, कैलकुलेशन में ये चीज ध्यान देना है कि अगर ये F1, F2 मतलब noise figure for stage 1, noise figure for stage 2, all are given in, if these are given in dB, then you should first convert it into fraction and then calculate. And if in the question it is asked to find the noise figure or the equivalent noise figure in dB, तो पहले फ्रैक्शन में जो भी dB में जो नॉइस फिगर dB में दिया हो उसे हम रेशियो में करेंगे और फिर लास्टली उस रेशियो को dB में कन्वर्ट करेंगे. ठीक है, तो ये चीज ध्यान रखना है. नॉइस फिगर जब भी कैलकुलेट करेंगे या गेन कैलकुलेट करेंगे, तो जब इन फॉर्मूले को पुट करेंगे, देन हमें ये ध्यान रखना होगा कि F1 सारे वैल्यूज जो है फ्रैक्शन में करके हम कैलकुलेट करें. ठीक है, तो अभी एक छोटा सा एग्जांपल लेता हूँ. ओके, so the question is that there are two-stage amplifier. There is a two-stage amplifier. Okay, so there is a two-stage amplifier with stage 1 and stage 2. Okay, with the input at this side and output at this side, with some data given, which are given as F1 as 2 dB and A1 for this stage is 12 dB. So this is the first